A pleasant greetings to all. In this video, I am going to explain a problem in control system that is coming under block diagram reduction. See the problem. The transfer function of the block diagram is given. I am going to find out the transfer function. Okay, first of all, I am going to draw the block diagram separately and then I am going to solve this problem. First convert this into signal flow graph, then I am going to solve the problem. So to convert the signal flow graph, the summing point you have to put a dot and takeoff point also you have to put a dot. So how many dots here? That is total number of 6 numbers of dots. So draw the dots separately. 1, 2, 3, then 4, 5 and 6. Then connect all the dots together. Okay, so first put R and second this is a summing point. Okay, between is there any gain is there? No, 1. And between this is there any gain is there? There is no gain, put 1. And between this takeoff point and the summing point we are having the gain 4 divided by S. And between the summing point and this takeoff point we are having 1 by S. And between this there is no gain, have to take us 1. Then y is the output. And between this point, the point number 3, between this point number 3 and the point number 4, we are having the signal gain, that is 2. And then the point number here, this is 1, the point number 2, and this is the point before the last point. So both are connected together by the gain minus 1. See, it is connected to minus 1. Now I am going to apply the Mason's gain formula to find out the transfer function. So what is Mason's gain formula? T is equal to 1 by delta into summation Pk delta k. So Pk is the forward path gain and delta k is same as the delta is not touching the kth forward path. Delta is equal to what? 1 minus sum of individual loop plus sum of gain product of two non-touching loops and so on. So first of all I am going to find out the number of forward path. Forward path is the path between input and output, that is known as forward path. Okay, so this is the one of the forward path. So first of all I am going to write the equation of the forward path, that is P1. P1 is 4 by S into 1 by S, 4 by S square. And next find out the next forward path. So the next forward path is, it starts from this and it is going to this and end at Y. So I am going to write the gain equation of the next forward path also. So next forward path P2 equal to what? 2 by S. This is the second forward path. After finishing this, find out the loop. So how many loops? There are 2 numbers of loops are there. So first loop I am going to mark the loop number 1. So it is start from this point and it ends at this. Okay, here 2 by S. So loop number 1 is 2 by S. And then I am going to explain the loop number 2. So loop number 2 is here, this is the loop number 2. So loop number 2 is what? That is equal to 4 by S, that is this is minus 2 by S, 4 by S into 1 by S minus 1. So 4 by S square. So now I am going to find out the T value. So T is equal to what? Summation of forward path 4 by S square plus 2 by S, the whole divided by 1 minus sum of individual loop minus 2 by S minus 4 by S square. Okay, next I am going to take the LCM. LCM is 4S plus 4 plus 2S divided by S square. Here 1 plus 2 by S plus 4 by S square. Here also find out the LCM. So numerator value is 4 plus 2s by s square. Denominator the value is s square plus 2s plus 4 the whole divided by s square. S square cancel. Finally get the answer 2s plus 4 divided by s square plus 2s plus 4. So option number A is the correct answer. So will we convert the block diagram into signal flow graph? It is easy to solve the problem, easy to find out the transfer function. Thank you. Have a nice day.